Hello, good morning, and welcome to the final session of this particular online program. So today, as you can see, I directly have the GNS3 screen open in front of you, and it has two routers additionally put up as part of the topology. Now, today what we're going to focus upon is the same process of installation of certificates and stuff like that, but instead of utilizing the firewalls, okay, we already have the VPN tunnel up and running between the two firewalls, but today we are going to set up a VPN between ASA1, which is going to be like our HQ-based device or HQ-based VPN device, and between that HQ device and the router, that is router R3, we are going to set up a tunnel, and our internal network is going to be 192.168.30.0. So before I even start off with the certificates and stuff like that, I'll make sure that I go ahead and first configure the two devices, that is router R3 and router R4, so that they are part of the topology and they have the IP addressing and all of that set up right. Okay, so I'll start off with router R3 first. And as you can see right now, nothing has been configured out here. So let me quickly go ahead and do the configuration there. So of course, I mean, at this point, my machine is doing very well because as far as performance is concerned, of course, it does have a spike in between, like wherein it tries to reach up to 100%. But let's hope it does not affect the entire config as such, Or if we find that it's really like affecting the entire config, what I'll try to do is maybe I can just switch off ASA2 for a while and then continue with R3 and R4 and ASA1. So maybe that should ease up on the resources. So now I'm not configuring NAT on this particular router. I mean, just for a simple reason that, resources are like at a premium at this point with regards to this machine. So I'll just try to keep it minimal as possible. I'll also quickly get on into the ISP router and I'll add that new interface. So that should pretty much do the entire setup config. But what I'll also do is I'll just make sure that I'm able to do reachability tests from the, let's say, the ISP router. So that's the new router R3 that I've added, and I'll go into router R3, and from R3, I'll try to ping 192.168.30.10, that is R4 that we added. And we do have reachability there. So things are good. I mean, at least the basic stuff we have taken care of. And of course, I have not configured any NAT, but anyways, when we start off with the VPN config, the NAT is supposed to be bypassed, right? So at least for this particular scenario, I'll not put up NAT, and I'll just directly go ahead and do the necessary config that we want, right? So going forward, let's quickly get on into router R3 at this point, and I'll try to check on the reachability to the CA server that we have, okay? So from R3, I'll try to connect to 100.0.100.150 and port 80, and it says gateway or host down, okay? Let me check up on my 2008 server. Okay, it's 150.0.150.100. Sorry about that. I just for a while got lost on my IP addressing. There you go. It shows open, so which means I do have reachability from the machine to the CA server, or from my router to the CA server. So that is good. So let's go ahead and quickly do the config here. Now, let me ask you this, you can maybe respond back in the chat window. So do you want to take a look at the installation of the certificate through the simple certificate, or do you want to look at the manual installation? Okay. As such, when it comes to the manual installation, it's exactly similar to what we saw with regards to the ASA firewall. So, I mean, command line also does not change at all. So, I think just to make it a bit quicker, let's say we go in for configuring it using the simple certificate enrollment protocol. Okay. Okay. Yeah. So again, the steps or the processes are going to remain the same in the sense like I'll first of all go ahead and define a domain name. Okay, just like the way we did it on the ASA firewall. So IP domain name. And for this example, I'm going to keep it as let's say vpn.edu. Okay. Now, of course, that's like a strange domain name that I've configured, but I just wanted to keep it separate or different than what we had all this while. So I'll just keep it as this. Okay, vpn.edu. And now let's go ahead and configure the key. So crypto key generate RSA. And then I'm going to define, now here I need not define a label. The reason is by default, whenever it generates a key, it's going to generate it according to the host name, that is r3.vpn.edu. That is the way it's going to do that. So I need not worry about that at all. The only thing that I need to worry about is the modulus or the key size, which in my case, the moment I press enter, it's going to ask me for the key size anyway. So as you can see, by default, the key size is going to be 512, but I'm going to change it to 1024. And as I mentioned earlier, the name for the key is going to be r3.vpn.edu in this example. So I'll just press enter there. And as you can see, the key has been generated. I'll just go ahead and save it. So my private key for router R3 has been created or generated. But now let's go ahead and create a trust point so that you can connect to the CA server and request or download the certificates. Okay. So to do that, I'll type in crypto. Now here, the CA command, okay, is available. Plus there is PKI also available. Okay. Now we need to make sure about what command goes where. Okay. So in here, if I type crypto PKI and put question mark, and that's where you can see the trust point and these kind of options. But saying that, if I talk about crypto CA and question mark, again, you find trust point and authenticate and certificate. Okay. Now, one of the things that you need to understand is if I look at the version of the iOS that is running on this router, the version of iOS is 12.4. Okay. 12.4 iOS may or may not, again, depending on the platform or the type of iOS version that I've installed, may or may not support both of them, in the sense like in this router, as you can see, it's supporting both crypto PKI as well as crypto CA. But on some other routers, you may find it's only crypto CA commands or only crypto PKI commands. Okay, so that's the main thing about it. So you just need to watch out for those commands here. So let's say for my example, I'll use crypto PKI because in the newer versions, it's called crypto PKI. And then I'll type trust point. Okay, and I need to give it a name. So let's say I'll just use that standard name which we have been using all this while. And then I'll type enrollment. Okay, and now Here, I do have the option of defining an enrollment mode, and as you can see, enrollment mode, I'm going to define it as RA or registration authority, because the router, even if I do not define this command, it's going to connect to the registration authority anyways, but we do have the choice of defining the enrollment mode as the type of server to which we are trying to connect to. Okay, so I'll just type enrollment mode RA, then enrollment URL. Okay, and I'm going to type http://150.0.150.100, that's the IP address of the CA, /certsrv/mscep/mscep.dll. Okay, that same standard URL which you've been using all this while. Okay. The next important thing is, if I put question mark here, you do have the same kind of commands like what we had in the previous cases, like we have the option of subject name, we do have the option of RSA key pair. Now RSA key pair would be useful if you have multiple keys, but in our case on this router we are just using the standard default key. So even if I do not define the RSA key pair, it's automatically going to use that default key that we used and generate the certificate. Okay. Apart from that, we do have the option of CRL options. Okay. Apart from that, we also have revocation check. So let me quickly go ahead and put up revocation check none, and I'm also going to define FQDN so that the certificate will include an FQDN. So I need to basically define the fully qualified domain name. Okay, so FQDN, I'm going to define it as r3.vpn.edu. Okay, so that's going to be my FQDN there. Apart from that, I'll also define subject name, just like what I've been doing all this while. Okay, so subject name, I'll keep it as OU equal to, let's say, for this particular thing, we'll just give it a name of, let's say, lab office, okay, comma, CN equal to R3, comma, DC equal to VPN, comma, DC equal to EDU. Okay, so I'm just going to include this kind of an information there. Apart from that, I'll also type serial number so that it includes the serial number. And then I also want to define or include IP address. Okay, so the IP address that I'm going to include out here is going to be 50.0.50. Let's say 2. That is the IP address of R3 itself. Okay, now that is done. I'll also type revocation check none so that it does not look up into the URL or into the CRL, that is certificate revocation list. Okay, so I think that's pretty much done with regards to that. I'll just save it here, and I'll also type do show run pipe to section and trust point. That will make sure that I'm able to review what I just did. And as you can see, that's the configuration that I did. Okay, so I've included the FQDN, I've included the IP address, and I've also included the subject name and also the serial number. And I think I'm pretty much ready to now go ahead and download and request the certificate. So I'll just type exit here, and then crypto PKI authenticate, and the name of the trust point, that is WinCA. And when I press enter, this is going to be basically a request for the CA certificate. So I'll just press enter, and it's saying error saying saving certificate and the status failed. And as you could see, the reiteration of the certificate, the time settings on the router being absolutely important. Now that's one of the main things. It says certificate not yet valid or is expired. Okay, so it was not able to save the certificate, but did it download the certificate? That's what we want to check up right now. So for that, I'll type do show crypto PKI certificate, and as you can see, here, it has not even downloaded the certificate. The prime reason is if I type do show clock, okay, the clock settings are way off. It's like March 2002. Okay, and that's the reason it's not working up. So let me go ahead and change that altogether. Okay, so clock time zone. Let's say I keep the time zone as, for example, in this case, Thai again and 7. Okay, and then the next thing that I want to do is set the clock setting. So clock set, and I'll define the time as 08:21:45 space today's date, that is 03 December 2016. Okay, so that should do it. Now, if I type in show clock again, I should see that the clock is 8:21, okay, which is similar to what we had. Now, config T, the next thing that I'm going to do is I'll just change back the time zone back to like some other time zone altogether, okay, because I already have a time zone of Thailand for ASA1, so I just want to keep it something different here. So let's say for now, I'll just keep it as Central Standard Time, okay, wherein the time zone is -6, or the time difference is -6. And then I'll also put up clock summertime, that's daylight saving, CDT, and recurring. That's what I'm going to define so that the clock settings are done correctly. Done. So that is done. Okay, and if I type show clock, as you'll notice, it's currently showing 1922. Okay, so which is like appropriately the number of hours behind. Okay, now, so that's good. I mean, and at this point, if I go ahead and request for the certificate, okay, let's see whether that works. So crypto PKI authenticate WinCA, and as you can see, now it definitely goes ahead and asks me to accept the certificate. I'll type yes. And there you go, TrustPoint CA certificate accepted. Okay, now I'll just go ahead and quickly save it. The next thing I want to do is I want to go ahead and enroll for a certificate. So for that, crypto PKI enroll and the name of the TrustPoint, that is WinCA. And there you go, it's asking me for a password. Now I can't just put up any password I want. I'll have to actually go into the CA server, open up the browser to get hold of that URL from where I can get hold of the challenge password. So mscep_admin, that's the URL that I'm going to use. It's asking me for the username and password so that it can verify the credentials for the service account. And there you go, that's the challenge password I want to utilize. So I'll just copy that. And I'll get back into router R3 now, and I'll just paste it, enter, paste it again, enter, and there you go, certificate subject name. Then again, it also says subject name in the certificate will include r3.vpn.edu. That's nothing but the FQDN. Apart from that, serial number and IP address is included. So request certificate, yes, and it says certificate request fingerprint is this, both MD5 as well as SHA-1, and this will help us to verify whether the appropriate request has been received on the CA server. So let's go into the server manager for that. That's this particular button here. And under here, under roles, if I just go ahead and expand our certificate authority role once it loads up. So there you go, Active Directory Certificate Services, WinCA. And if I click on pending request, there you go, that's our request out there. If I double click on it or right click all tasks and view attributes or extensions, I should see out here the subject alternative name as r3.vpn.edu. So that's the correct request. I'll just alt tasks and issue it. Okay. So now, if I get back into router R3, I should see in a little while that the certificate has been received. So just to verify it real quick, I'll type show crypto PKI certificate. There you go, it says certificate received from certificate authority. So now if I type the show crypto PKI certificates, I should see both the certificates. And as you can see, the certificate represents the identity certificate where it includes all these attributes. Apart from that, it also gives me the validity until December 2017. That's for 1 year. And then we have the CA certificate also available, which is valid for a period of 5 years. I'll just go ahead and save that. So at this point, I can state that R3 is now ready with regards to the certificates and every information that it needs. Okay, so if I type show clock as well, okay, it shows that everything is good because it says that the current time is 1926, and if I look at the certificate validity, that start date for the certificate validity is 1915 on December 2, 2016, whereas currently it's December 2, 2016, but 1926. So the certificate is definitely valid. Otherwise, it wouldn't have not accepted at all. Okay. So R3 is ready with regards to the VPN. But first, what we'll do is we'll do the necessary changes to the ASA one, which is going to be like a hub device or hub VPN device, wherein we'll add the appropriate parameters specific to this particular peer, and then we'll go into router R3 and do the rest of the config. Okay. So on ASA1, there's not much that we need to do really, because if I just type show run crypto, I would be able to see all the necessary commands. So as you could see, I'll basically reiterate on what all things do we need to go ahead and add. Okay. As far as policy is concerned, now if you want the same set of policies like what we did here, we can just leave it at that. We need not create or add another policy at all. So that's good. And we need not enable the IKE version 1 on any other interface because it is going to be the outside interface. So that's again good enough. The next important thing, when it comes to the certificate map, okay, now that's something that we need to go ahead and add up because this certificate map which you see is according to ASA2, wherein it's matching the OU attribute of US office, but we want to change that. Apart from that, we do not want to do any changes to the trust point at all because it's going to use the same certificate. But the next important thing that we want to do is for the IPsec phase 2, the transform set that we had used, if you want to use different parameters under that, again, you need to go ahead and create a new transform set altogether. Okay, but if I want to keep the same parameters, I'll just go ahead and use this existing transform set. But the main change that you want to perform is under CryptoMap CMap, I need to go ahead and add a different sequence number altogether. A different sequence number which will match a different interesting traffic. That is, instead of VPN ACL, which is what we had utilized the other day, we are going to use a different access list altogether, which defines the interesting traffic. The peer address is also going to change. The transform set can remain the same. The security association also can remain the same. Trust point also remains the same. Set reverse route also remains the same. So bottom line is, I just need to create another crypto map with a new sequence number. But before we go ahead and do that, we also need to go ahead and create a new interesting traffic or a different access list altogether for this particular VPN. That's one of the things that we need to do. Apart from that, we also need to go ahead and change or create a new tunnel group. Okay, so if I type show run tunnel group, I need to go ahead and create a new one, because for the new peer accordingly. Apart from that, I also need to go ahead and create a new tunnel group map. Okay, because the existing tunnel group map, as you can see, is configured for a default group of 200.0.200.2. Okay, and tunnel group map, ASA2 map is pointing out to this particular thing altogether. So I need to change that so that it becomes generic or it becomes general, okay, with regards to our config. So let's go ahead and do that. To do that, first of all, what I'll do is, okay, now IKE version 1 policy and all of that, I want to keep those parameters the same, so I'm not going to change that at all. So I'll directly start off by creating an access list. So access list, and I'll give it a name of ASA1 R3. Okay, indicating that it's a interesting traffic or an access list between ASA1 and R3. Permit IP from 192.168.10.0, 255.255.255.0 to 192.168.30.0, 255.255.255.0. So that takes care of the interesting traffic. Okay, I'll just quickly go ahead and look at my device performance. Okay, it seems manageable or good enough at this point. Next, the next thing that I want to do is I want to go ahead and create a tunnel group. So tunnel group, and I'll define the IP address of my peer, that is 50.0.50.2 type IPsec-L2L, and then I'll type IPsec attributes, and under that, okay, we need to define the similar parameters like what I had defined the other place. So I'll just put up these two things. I mean, basically a simple copy and paste will do. Okay, so there you go. So same parameters will come up out here. Next thing, okay, after I've configured the tunnel group, the next thing that I want to do is I want to go ahead and create a certificate map. So let's go ahead and do that as well. So I'll define crypto CA certificate map R3 map, and let's say sequence number 1. And under that, I'm going to define the subject name attribute, okay, to match OU equal to lab office. Okay, that's what I had created as a OU name for this particular router R3, and that's what I'm going to define as the attribute out here. The next thing that I want to define is, okay, once I've defined this, the next thing that I want to define is the tunnel group map. Now, in this case, the tunnel group map is already enabled for the rules, and the default group is defined as 200.0.200.2, but that means it's only going to be specific to ASA 2. Okay, so I just want to change that first. But before I go ahead and do that, I'll also put up a map according to this one. So what I'll do is I'll type in tunnel group map, R3 map 1, and then I'll point it out to 50.0.50.2, which is nothing but the IP address of R3. And then the next thing that I want to do is I'll type tunnel group map and then default group, and we'll define the default group value. Instead of 200.0.200.2, I'm going to keep it as default. Okay, now see, it's just asking me for a word, so it's going to be L2L group. Okay, now where do I get this value from? Well, for that, what I just need to do is I'll type show run all tunnel group. If I type this command, it's going to give me a list of all the tunnel groups, and that's the group that I'm talking about. Okay, default L2L group. Okay, that's what I can define. Okay, so that's what I'll use here. So tunnel group map, default group, default L2L group. The next thing that I want to define is, okay, I'll go into tunnel group, default L2L group, IPsec attributes, and I'll also make sure that I define peer ID validate as no check, just so that it does not go for the peer ID validation at all. Okay, the reason is I did this thing because for the default L2L group, as you can see, peer ID validate is set to required. Okay, so I just went ahead and removed that. Okay, so I just kept it as peer ID validate, no check, and it's kept as no IKE version 1 trust point. So I'll just go ahead and put up the IKE version 1 trust point as we'll see, so that we do not lose out on our certificate related information at all. Okay, so our tunnel group map and our certificate map also has been configured. The next important thing is I have to type in crypto. Okay, first of all, I'll type show run crypto map so that I can see the existing crypto map, and I can go ahead and create a new one. Okay, so crypto map, I'll define crypto map C map, and then number 2, that's sequence number 2, match address. I'll define it as ASA1-R3. Okay, that's the name of the access list that we want to configure. Then, now it's giving me a warning saying that crypto map entry is incomplete because I just defined the address. It also needs the peer information and all of that. So it's not like I've put up an error or a wrong configuration. It just needs these additional configs as well. Okay, so let's go ahead and do that. So let's say we define set PFS group 5. Same thing like what we did earlier. Again, it's saying incomplete because it still needs the peer command. So set peer 50.0.50.2. Still it says cryptomap entry is incomplete. Okay. Then set IKE v1 transform set trans. That's the name of the transform set. Okay. Now, as you could see, the cryptomap entry is incomplete message is no longer coming up because it has got hold of all the commands that it needs. Okay. So that's why it does not come up with the message. Set security association lifetime second 28800, and then set trust point WinCA, and then I'll also define set reverse route. That. So our crypto map also has been configured according to the second peer. So if I type show run crypto map again, you'll see both the sequence numbers are there and it has the 2 peers that we want. Okay, so that's taken care of. So ASA1 is now ready. Now let's go ahead and configure it for R3. So I'll get on into router R3. And as far as router configurations are concerned, things are a bit different here. So it's going to be config T first, and then crypto ISAChem enable. Now this command is not really important because by default on a router, ISAChem is enabled. So we need not worry about enabling the ISAChem at all. Then crypto ISAChem policy, let's say 1. Authentication RSA signature. Okay, that takes care of the digital certificate authentication. Encryption, we want to use AES 192-bit. Hashing, we want to use SHA. Group, now the group that we have is 1, 2, and 5. So we want to use group 5 according to our config on ASA1. Then lifetime. Now this lifetime value need not match with that of ASA1, but in our case we'll just keep it as 28800. Okay, and I'll just type exit. So that takes care of the configuration of the ISAChem policy. The next thing that we want to define is a certificate map. Okay, so let's go ahead and do that. So crypto CA, or yeah, crypto CA certificate. Yeah. Now we can type crypto CA certificate, or we can also type crypto PKI certificate map, and then we can define attribute map tag or a name given to that. Okay, so let's say for this example we want to keep it as ASA1-map, and then we want to give it a sequence number just like the way we did it on ASA. So there you go. And once I've done that, the next thing that I want to define is we want to define what we want to match under that. Okay, so let's say subject name, and then just like the ASA, we have contains, equal, does not contain, not equal, but it does not have option like attribute or anything of the sort. Okay, so that's why in this case I'm going to keep it as subject name contains, or CO, that is contains. Let's say I'll keep it as ASA1. Okay, so it will only look out for this word or this particular text or string under the subject name, that is ASA1. Okay, so that's the only thing that I'm going to define. No other criteria, so no other configurations here. I also have the option of defining expiration date, or depending upon an expiration date, or I can also define it based on an issuer name and stuff like that. Okay, but right now I just keep it in this fashion. The simplest possible config is what I'm doing out here. Once I've done that, the next thing that I want to define is I want to define this certificate map somewhere. So that's why I'll configure, or I'll go ahead and configure crypto ISAChem profile, and I need to give it a name. So let's say I give it a name of R3 profile. Okay, so remember, for creating a certificate map on a router, we need to go ahead and configure an ISAChem profile. Okay, so once I've done that, it's coming up with a message saying that this profile is going to be incomplete until it has a match identity statement. So let's go ahead and do that. Match identity, and then we need to define what do we want to use as our identity. Okay. Now, when it comes to a certificate, the best option that we can go in for is we can match identity, or we can type match identity, and then we can define the address, IP address of the peer. So in our case, the IP address of the peer is going to be address, and then we need to define the IP address. That's going to be 100.0.100.2. That's the IP address of the peer. Okay, and then we can specify a mask, or we can just go ahead and press enter. Okay, so there you go. That's the match identity command that we defined. The next thing that we want to define is I can also define a self identity if I want. Self identity again, should it be based on IP address or should it be based on SQDN? Such kind of options are available. So let's say self identity, I'll define it using an address. Let's say that is 50.0.50.2. That's the IP address of the router R3. Yeah, okay. Now I just need to type self-identity address. That's about it. It will automatically take the IP address. Okay. So yeah, once I've done that, the next thing that I want to define is I want to define the certificate map. Okay. So for that, the command would be CA trust point, and the name of the trust point, that is going to be WinCA. Okay, and that will take care of the trust point itself. The next thing that I want to do is I'm just verifying whether I have completed all the config that we need. It seems like we have completed, or we have added all the components. Okay. Now, of course, this initiate command that you see here, this is what is typically used to define whether we want to use aggressive mode. Okay, but right now we are not going to get on into that. I've already defined the CA, or certificate authority to trust, and okay, I'll also type match, and yeah, I defined match identity address, right? But I can also type match certificate, and then we can define the certificate map, because that was the primary intention, or that was the primary reason why I created this particular ISACM profile. So the certificate map was ASA1 hyphen map. Okay, that was the name that I gave. So there you go. That's done here. So my ISACM profile is also, ISACM profile is also created. The next thing that I want to define is I want to configure the interesting traffic. To configure the interesting traffic, okay, I'll just type do show access list just to make sure that I do not have any access list. Yeah, so access list, and let's say I define 101 because it's a router, so a numbered access list will also do. Permit IP 192.168.30.0 0.0.0.255, again because it's the router, 192.168.10.0 0.0.0.255. That takes care of the interesting traffic. The next thing that I want to do is, once I have configured this one, interesting traffic, I need to now go ahead and define the phase 2 parameters, that is the transform set. So crypto IPsec transform set, let's say we give it a name of trans, ESP-AES 192 and ESP-SHA-HMAC. That takes care of the transform set. Okay, so that's phase 2 completely. Now, once I've done that, the final thing that we want to do is we want to define the crypto map. So crypto map, let's say C map, and then we need to define a sequence number. Okay, so sequence number of 1. Okay, and then we need to define the IPsec-ISACM that indicates that I'm going to use IPsec-ISACM. The next thing that I want to define is set peer and the IP address of the ASA, that is 100.0.100.2, match address 101, that's the interesting traffic. Then set ISACM profile and the name of the ISACM profile that we created, that is, what was it? Okay, let me just quickly check that up. I think it was R3 profile, but I'll just cross check that real quick. Yeah, it was R3 HACM profile. So I'll just copy and paste that. So set HACM profile of R3 profile. Okay. Then the next thing, okay, set, I'll just also type reverse route so that it can automatically include the route. Set transform set trans, that takes care of the transform set. The next thing that I want to do is set security association lifetime seconds and then 28800, for example. That's the next thing. Set PFS group 5, that's the perfect forwarding secrecy. And then after that, okay, we do have all these options, and I think I have pretty much covered whatever we need. I've defined the peer and all of that. Okay, so that should take care of this aspect here. So as you could see, there was no option of trust point definition or anything of the sort. So that's why we had to define the ISACM profile. Okay, so that took care of that. So once I've defined the crypto map, the final thing that we want to do is we just want to get on into the serial interface or the external interface, and I'll type crypto map serial. That will make sure that the ISACM is turned on. There you go. Okay, so configuration is complete. Okay, so let's now go ahead and quickly do a check with regards to the tunnel formation. Okay, so for that, what I'm going to do is I'm going to first of all enable debug on this particular router. So debug crypto ISACM. Okay, but before I do that, I'll just quickly check up on the performance. Yeah, it's still at around 81%. So I think it should do good, but let's do a quick check according to that. Okay, so debug crypto ISACM. And now let's get on into router R4. I'll type show IP route. So it does have the default route. So let me go ahead and ping 192.168.10.10. That is nothing but the router behind ASA1, that is R1. Okay. So R4. Yeah, let's try to do that. Okay, so it did not work. But now let's also check up on the router R3, whether it has generated any kind of message. It did, okay, as you could see here. Okay, it did generate some messages. It is definitely generating all these messages, constructing certificate, found matching profile. So it is doing something, okay, for sure. But I just would do a U all or undebug all just so that the message is stopped. And I'll type show crypto ISACM SA. And as you could see, you know, it is getting stuck at no state. So bottom line is, you know, something is going wrong. I mean, in the sense like it is trying to create the tunnel, but after that it's failing. Okay. So I'll just quickly go ahead and check what's happening there. So let's take a look at the debug. Yeah. So it starts off from here. It says SA request profile is R3 profile, created a peer structure for 100.0.100.2. Okay, and it says ISACM initiator and insert SA successfully, cannot start aggressive mode, so it's trying the main mode, like I said, and it says profile has no keyring, so it's not going to search for any pre-shared key or anything of the sort. Okay, and that there you go. It starts off with main mode message 1, wherein it's starting off with the main mode, and it's trying to connect to 100.0.100.2. IKE message from the peer. There you go. It's going in for main mode message 2. Okay, and it says looking for exort in the profile R3 profile, and it's checking up the ISACM transform 1 against the priority 1 policy, and it's checking up all the encryption parameters. And it says attributes are acceptable. So things are good here. You know, phase 1 policy is a match. Then now it's coming up with a NAT part of the config. It's saying vendor ID is NAT-T version 2, processing vendor ID payload, but major 194 mismatch. Okay, that's because I mean there is no NAT configuration here. But look at this: constructing cert request, for issuer CN equal to WinCA, sending packet from 100.0. Packet 2, sorry, 100.0.100.2 on port number 500, and it says ICE process complete. So bottom line is message 2 is also done. Now it's going in for message 3, and under message 3 it's saying processing cert request payload. Peer wants a CT X509 signature certificate. Peer wants certificate issued by examining profile list for the trust point WinCA, and it did find a matching profile for WinCA. Choosing a trust point WinCA as the issuer. I'll just scroll down. Processing vendor ID payload. Vendor ID seems Unity DPD, but major 201 mismatch, and vendor ID is XOR. Okay, so we'll have to just check what's happening here. There you go. Vendor ID seems Unity, but hash mismatch is what it's saying. Send initial contact. SA is doing RSA signature authentication. Let's scroll down and check that. It's saying address 50.0.50.2 and constructing the certificate. There you go. That's the certificate credentials, the certificate information that it's making use of. And it says ICE process is complete. And that's the certificate that is utilizing. But it's saying expected R3 profile doesn't match, aborting exchange. And that's where something is going bad. Okay, so that's where something is definitely going wrong. So I think I'll have to look back into my R3 profile, to find out what's really failing out here. Okay, so maybe it's like something when I typed in, something went wrong there. Okay, so let me quickly check that out. So what I'll do is I'll type show run pipe to section profile. And when I do that, it should show me the ISACM profile, and it shows that crypto ISACM profile R3 profile. Okay, self identity. Okay, match identity address, match certificate. Okay, so I think it's coming up with some redundant errors here. So what I'll do is, what I mean by redundant error is like I have two match commands, right? So maybe it's trying to match the identity using the IP address instead of the certificate and all of that. So that's where like I think it's kind of getting into a loop. So I'll just go ahead and clear off the redundant aspects. Okay. So what I'll do is I'll keep self identity as instead of address, I'll keep it as FQDN. That's one of the change that I'll carry out. Then the next thing that I want to do is I'll type no, and I'll remove this match identity command. Match identity address. Instead, I'll just keep it as match certificate, and I think that should do it. So let me just save it and recheck it. Okay, as to what does it have now. So that section profile, and as you can see now, the self identity is FQDN, CA trust point is WinCA, and match certificate ASA1 match. So I think now it's much more specific with regards to the certificate. There are no redundant options which it needs to go for. So let's go ahead and now do the check again. Okay, so I'll just do the debug again, and let me now try to do the ping again. So ping 192.168.10.10. So definitely there are some messages that have started to exchange now. Okay. So it is checking the IPsec proposal as well. So which means I think it is kind of working, but no, there is some error still. So let me disable the debug, and let's check what's going on with that. Oh, okay, setting new node to QM idle. So it did definitely work, it seems like. So let's check that out. No, it did. Okay, no problem. So now let me check show crypto ISACM setting. And yeah, phase 1 is definitely achieved. So the ping still does not work. So that's something that we need to check. But the next thing is I'll type show crypto IPsec setting. Okay, so packets are getting encrypted, but they are not getting decrypted. So there is something wrong with the access list, it seems like. So I need to cross-check the access list, the mirrored access list, the interesting traffic. That's what I need to make sure about, because the tunnel is definitely created for sure. Let me also get on into ASA1 and check up on that. So show crypto IP1 SA. And as you can see, it's definitely showing active. That's good. And show crypto IPsec SA. It's definitely showing 14 packets decrypted. So bottom line is, traffic is flowing one way. It's not flowing the other way around. So that's what I need to check up upon. So what I'll do is I'll just type show access list. And when I do that, it's showing ASA1 R3, and it shows 192.168.10.0, 192.168.30.0. So this is good. Okay, the access list on ASA1 seems good, nothing wrong with that. But now let's check up on the R3. So show access list again on R3. And here it shows 30.0 to 10.0, and there are 25 matches. So that also seems good. Okay, show run 5 to section crypto map. And we do have 100.0.100.2, set transfer, set trans, set PFS group 5, set ISACM profile and path3 profile, match address 101. So it seems good here. Nothing wrong with that. Okay. Similarly, let me type show run crypto map here. Seems good here as well. Let me also check show route just to make sure whether it has the routes accordingly. It does have a route automatically created, a static route which says 100.0.100.1. Now let me check up here. Show IP route. It should have a static route created automatically. That is 192.168.10.0 going via 100.0.100.2. Okay, so it has it is directly trying to point it out to 100.0.100.2. Okay, so which also makes sense because it is created automatically. It's not like something that I created. And what I'll also do is ping 100.0.100.2. Yeah, it does have reachability to ASA1. So there's nothing wrong with that at all. So let me get on into R4 again and let me try to do the ping again. Yeah, so it's not working at all. Okay, so something is going wrong somewhere. That's what we need to check up, or that's what we need to find out as to what's happening there. The next thing, what I'll do next is I'll try to clear out the tunnel here. I'll try to initiate the tunnel from the other end. Let's see whether that does it. Okay, so clear crypto SA and clear crypto ISACM. That will clear out the tunnel. Okay, and if I type show crypto IPsec SA, there you go, it's cleared. And show crypto version 1 SA, that's also cleared. So now what I'll do is I'll get on into router R1 and I'll try to do the check again. So ping 192.168.30.10, that's the IP address of R4. Okay, here also it seems like the tunnel is not created, but let me try that again. And while that's happening, show crypto IPsec version 1 SA. Yep, there are no SAs created. So bottom line is something is going bad with regards to the configuration here, because ASA1 is not initiating the tunnel or creating the tunnel. Okay, that's what is happening out here. So that's what I need to check as to what's going on. So show access list again. Yeah, so it is not finding any hit counts here. It's not finding any hit counts related to this particular traffic here. So 192.168.10.0 going over to 192.168.30.0. So let me type show route. It does have the route. static route or reverse route is definitely there, but the tunnel is not getting initiated. Okay, so show run crypto map, match address ASA1 R3. That's correct. So let me type show no, actually, that NAT is what I was trying to skip. I did not want to create the NAT because even if you create the NAT, you have to like bypass it for the VPN anyways, right? So I might as well thought of not utilizing the NAT at all. Okay, so that was my whole idea because I'm using default routes anyways on the devices, so that should do it right now. So basically, my idea was like on router R3. Okay, there is no NAT at all. So for the VPN, it will directly try to go through the tunnel in that case. No need to do that additional config of bypassing the NAT and stuff like that. Okay. So let me check up on why is it not initiating the tunnel. So show access list again. Yep, as you could see, I mean, it shows definitely a hit count here of 1, but when I try to do the ping again from R1, for example, 192.168.30.10, there is no hit count at all. I mean, it's not increasing at all, It is just that initial 1, that's about it, but nothing more than that. So that's what is causing the problem. So let me type show run crypto map. And ASA1 R3. Yeah, I was just cross-checking whether the access list name was correct. So that is correct. Nothing wrong with that. And how about router R3? Okay, let's check whether it has created anything here. Show crypto ISACM Pete. Yeah, it's not going to create anything because ASA1 itself is not initiating the traffic for some odd reason. Okay, so let me type in debug crypto IC V1 and let's say 130. That's the debug level. And based on that, let's now go ahead and check it up again. Okay, so I'll get on into router R1, and from R1, I'll try to ping 192.168.30.10. And when we do that, if I type show logging, okay, I think I had disabled it. Logging on. Yeah. So based on that, now let's check it up again. Okay, so there. Now we are getting something here saying built dynamic ICMP translation. Oh, okay. I think I understand your point now. Actually, what happened was, yeah, we had an exception created on ASA1 for the older traffic, that is between 192.168.10.0 to 192.168.20.0, but we never created an exception for between 192.168.10.0 to 192.168.30.0. Yeah, I understand your point now. Sorry about that. Okay, I was like too engrossed in thinking about something else altogether, I guess. But yeah, okay, good you brought that point to my notice. So let me quickly do that. Okay. So yeah, basically the problem is I'll just do that real quick. Okay, so let me type show run NAT. Okay, so basically I do have this config, but that's only between ASA1 and ASA2. But I want to configure one more thing there. Okay, so let me create another object. So object. Sorry. 150 object network, okay, and this name that I'm going to create is DST1-NW, and then subnet is going to be 192.168.30.0, 255.255.255.8. That's going to be my new subnet, okay. So basically, I would have a new NAT statement that I need to configure. So what I'll do is I'll just copy and paste the same line, but the destination is going to be DST1-NW space DST1-NW. So I'll have two different NAT statements out there. Okay, so let me just show that to you. Show run NAT, and as you can see, now I have two different NAT statements, and that should bypass the traffic that we are talking about. So I'll just save it, and what I'll do next is, so this time it was not because of my access list, it was more to do with the NAT configuration missing on ASA1. Okay, so yeah, now let me go ahead and disable the logging, so that I mean, I'm sure that is going to definitely work. So I'll just disable the logging altogether. And now, because of that, let me now try to get on into router R1. And I'll try to establish the tunnel again, okay? But while doing that, I'll also make sure that R3 has the debug running. So show debug. Yeah, debug crypto ISACM. Now, while that is on, I'll just get on into router R1. I'll just keep it here so that we can see the debug messages on R3, okay? So 192.168.30.10. There you go. I started getting the thing. Okay. So yeah, it's working, and let's wait for the messages to stop, and then we'll be able to understand what's going on, or we'll be able to review all the messages that are happening out there. Okay. And there you go. On ASA1 also, we are able to see all these different messages generated because of the debug that I had created. So while that is happening here, what I'll do is I'll just quickly disable the debug here on the ASA. And let's review the debug messages on the ASA, and once it completes on R1, we'll get on into that, okay? So as you could see, on ASA1 it says, okay, I'll just quickly disable the debug here as well. We can review that later, but right now, new phase 1 interface inside, peer, this one, local proxy, remote proxy, so it's talking about the interesting traffic. It's saying ISACM festive payload, okay? Then I'll just scroll down a bit, there you go. Oakley proposal is acceptable, okay. Then constructing cert request payload, okay. And there you go. So constructing RSA signature, and that's the signature that is constructed. Now, constructing iOS keep alive payload, okay, proposal, time and stuff like that. Okay, so it's showing that. It's saying automatic NAT detection status, remote end is not behind a NAT device. Basically, it's telling that the peer is directly reachable, not behind a NAT. And there you go. It has found the router ID or FQDN, that is r3.vpn.edu, which is what we have defined as the self-identity on router R3. It's processing the cert payload. Now it's processing the certificate itself. And there you go. Trying to find group via cert rules, and connection landed on the tunnel group 50.0.50.2. Okay, where peer ID type 2 received, that is the FQDN. So basically, it found that the peer ID matched and phase 1 was completed. And then when I scroll down further, now it's starting the phase 2. And when it comes to that, constructing quick mode hash payload, as you could see here. Okay. And then there you go. That's the interesting traffic or the proxy address and all that information, loading all the IPsec essays and generating quick mode key. And there you go. Security negotiation complete for LAN to LAN group 50.0.50.2. Okay. So basically it completed the negotiation out there is what it's saying. And then it says phase 2 completed. Okay. So that is on the ASA that we saw. But in a similar manner, if I look back at the messages on router, as you could see, it's much more informational, as compared to that of the firewall. And if I scroll down, there you go. local port 500, remote port 500. That's the ISACM for phase 1. Message 1 is what it's sending now, main mode message 1. And again, it's coming up with this major 1, 2, 3 mismatch, but that's more to do with NAT traversal and stuff like that. So that's not something that we need to worry. Then it's scanning profiles for extended authentication or R3 profiles. And it found that we do have an ISACM policy with a priority value of 1, and that's where all the attributes are. And it says attributes are acceptable. But again, later it's coming up with this message of mismatch, but that's again for the NAT traversal. I'll just scroll down further. So then it's going on into message main mode message 2. Then main mode message 3. That's where it's going to generate the certificate request or checking for the certificate. There you go. It's saying choosing TrustPoint WinCA as the issuer. And now scrolling down further, it says IKE process complete. Okay, so that was the message 3, which says constructing cert request for the issuer, and then message 4, okay, is what it comes up with. Message 5, it's where it's going to check up for the certificate authentication and stuff like that. And as you could see, that's the certificate that it received with regards to ASA1. It says Unity's identity group OU equal to Thailand office. Peer matches none of the profiles. That is what it's saying. Okay, but then later when I scroll down, okay, it says peers public key is in cached OU equal to Thailand office, and then it says certificate matches R3 profile okay, and it says trying to revalidate cert using the new profile and cert validity confirmed. Okay, so bottom line is it looked out for the trust point and it found the certificate information and it was able to authenticate it. See, so SA authentication status authenticated, and SA has been authenticated with 100.0.100.2, and then SA is doing RSA signature authentication, and that's the payload with which it will try to authenticate. And then it says using the WinCA trust points key pair to sign, and it says IKE process complete, and finally it says IKE P1 complete or phase 1 is complete. Now scrolling down further, now it will go in for QMIDL or the IPsec proposal, wherein it's going on into phase 2. As you can see, it's checking up all of that, and it says attributes are acceptable. And finally, when I scroll down, okay, as you can see here, we have all these checks out here, and it says QM done, awaiting. Basically, it's just waiting for the phase 2 to complete, and finally it comes up with IKE quick mode phase 2 complete. Okay, so that's what it shows out here. There. Yeah, there you go. Now the new state has become QM_idle, and then it's showing sending out the key pair messages, that is dead peer detection, are you there, and stuff like that. Okay, so this is what we had with regards to the site-to-site VPN between ASA and router R3. So if I type show crypto ISACM SA at this point, you should see that it's QMIDle, and if I type show crypto IPsec SA, it should show me the appropriate number of packets getting exchanged via the tunnel. It's only showing 7 because first time when we did the ping, only 2 packets were successful, and the next time all the packets went through the tunnel. So that makes it 5 plus 2, that's 7. Okay.
All right, can you hear me?
So yeah, one last check that I'll do is from R1, I'll try to set up the tunnel with R2. Okay, let's see whether that tunnel is still functioning. Okay, so I'll get on into R1, and from R1 ping 192.168.20.10. There you go, even that is working. So at this point, if I look at our ASA1, we should have 2 tunnels running out here. Okay, so show crypto IKE V1 SA, There you go. These are the two tunnels, one with ASA2 and the other one, this is R3 for that matter, and this is ASA2. And both of them, it shows that it's the initiator because the traffic initiated from the hub side. Okay, so things are good, and I would say that would be the completion of this particular session. Okay, so I'll just pause the recording right now, and we'll just discuss on anything else that we want to do. Okay.